All right, so a nice right isosceles triangle. I know the video kind of just quit there on me, but we'll see if this one works. 45-degree angle there. How am I going to find that missing side? What tool in my toolbox do I have to find that missing side? Pythagorean theorem. Okay, so the Pythagorean theorem would tell me then that x squared plus x squared is going to equal that missing side squared. Right? Okay, well, x squared plus x squared is 2x squared. So, Schmeling just said that he had somebody this morning, x squared plus x squared, that was x to the fourth.
That's what I would have said automatically.
Okay.
When I said 2x.
That's only if it's multiplication.
Well, everything in this class has been multiplication. I feel like.
That's not multiplication, though.
Well,
That's a
not
plus.
this. Oh my god.
Oh my gosh. Is that an oh my god or is that an ermagerd?
It's an oh my god. It's 2x.
Right? It's what?
2x.
So what do we do now? Square root both sides?
Sure. Why are we still getting a square?
Because we want to just get that side by itself. That's what we want. Right? So what is the square root of 2x squared?
No,
2x?
I know what we're trying to do.
How many people agree with 2x? You would be on the wall of shame. Okay?
It'd be it'd be square over 2, actually.
Oh, yeah.
No.
Square root 2x.
I don't know. That's my question.
You're trying to find x.
This is not that hard of a question, actually. I'm not going to lie to you.
X root.
The square root of 2x squared.
Oh,
What do you got there, Jaden?
X squared.
X times the square root of 2. Alright. Break it up into the square root of 2 times the square root of x squared. Square root of x squared is x. It is free. It is outside. Square root of 2 is not, though, because it's still inside. Okay? So we've got x times the square root of 2 there. Does everybody agree with, then, in a 45-45 right triangle, that we've got side lengths of x, and that gives us a hypotenuse of x times the square root of 2, based off of the math that we just did. Okay? Now, what I would like you to do, and I'll give you a couple of minutes, maybe 1 or maybe 2 minutes to do that. Now, I am going to set the 45-45 right triangle with a hypotenuse of 1. You find me the missing legs. Go. Okay? So if I do this right, x square roots of 2 now is going to have to equal 1. Left side here is in general always the case. Right side is where I set it equal to 1, so I can set left side hypotenuse equal to right side hypotenuse. Divide both sides by the square root of 2, and I get 1 over the square root of 2. Yes? However, in math, and you'll find especially on the unit circle, we like to have our denominators rationalized. So I'm going to multiply this by the square root of 2 over the square root of 2. And then I get an x value here of the square root of 2 over 2 for the lengths of the legs of my triangles. Side note, you also had a typo.
Is it untie instead of unit?
Yes.
I already fixed it. My I stole their binder. Those are last year's notes.
Like all the way through? Like, look at you. Wow. Give a guy his second year on a team and all of a sudden he takes off with it. this guy over here. Yeah. Yeah, he needs a lot of stuff to do. Okay, everybody agree with that? Okay. Now, on this next triangle, there was a typo before we went through it. Your 30-degree angle is in the wrong spot. Can you please cross off that 30-degree angle and move that 30-degree angle to the true spot that it should be? Okay. So the 30-degree angle should be up top,
I just wrote 60.
which means that the 60-degree angle should be in that lower position. Okay. Now for this one, if I were to take and reflect that triangle, now then this would be a 60-degree angle here. This would be a 30-degree angle here, which would make this whole angle there be 60 degrees. What kind of a triangle do we have? We have an equilateral, equiangular, a regular triangle. A regular polygon has equal lengths on its sides and equal angles for all of its angles. That would also mean that I would be reflecting the x to there, so that side length would be a total of 2x, which means then that this side up here is also 2x. See how that works out? Okay. Now, with that being said, it 100% is geometry. Now, with that being said, find me the missing side of this triangle.
Okay, that's not magic.
I don't know if that's right though. But I feel like it is. Seems like it.
I'm not enjoying this very much. That's okay. We got this. Oh, of course. We're missing parentheses.
Agree with all of that so far?
Yeah.
Yes?
Because
Okay.
otherwise-
Left side then is going to be x squared plus what I don't know squared. And that's going to equal, what does the right side equal? What does the right side of this equation? 4x squared.
Or that is not.
Then what?
Oh, because it's squared 2.
Because 2x squared is 2x times 2x, which is 2 times 2 times x times x, which is 4x squared.
The square root
Still,
of
if
x
you do it the way
the
that
square root
it
of 3x.
should be done in the brain, it doesn't work.
That's probably why we're not doing it the way it should be done in your brain.
See, you said I could do it in
No,
part
it's
one,
just
and
square
then
root of three.
I said no.
Is it just?
Whoa, 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 whoa.
Whoa. All I did was subtract x squared from both sides. If you got 4
3x
pencils and I take 1 pencil away, you only got 3 pencils left.
So then it's just the square root of 3.
So it's no, but the 3x is already squared.
I
No,
hate
'cause there's
addition.
3
I hate
x
addition.
squared.
And you know why? Because it's too
I did
complicated.
that last
So I get the missing side is x times the square root of 3.
I was really confident in my.
Good try though. Yes? Okay. So again, with that being said, now I'm going to set a 60-degree angle there, a right angle there, a 30-degree angle there, and I'm going to make this hypotenuse be 1. Find me all of the lengths, or the 2 missing lengths of that triangle. Go.
Wait.
Once again, we can set hypotenuses equal to one another.
English major
In high school.
So that would give me the missing side down here, the short side, would be 1/2. Yes?
Where'd you get 2x?
Because it's the hypotenuse on the general triangle. Now that's equal to 1 because I set the hypotenuse at 1.
This is wild. Okay, sounds good.
If that is the case, then this missing side is going to be the square root of 3 over 2.
Oh, because one.
How did I get that in there? Well, because on the general triangle, we found that we take whatever this short side, it's called the short leg, short leg times the square root of 3. We just found the short leg to be 1/2, so 1/2 times the square root of 3 is the square root of 3 over 2. Good? All right. Let's start talking about the unit circle. Yep. So the unit circle does truly have the equation of x squared plus y squared equals 1. There's a couple of things about that that you should know. First off, that is a circle centered at the origin. So the center of the origin, or the center of the circle, is at the point 0, 0. That is also a circle that has a radius of 1. So the distance from the origin of every single point on said circle is 1 unit. Okay? Now, what we're going to have on this circle is we're going to start here, and then we're going to have something called a wrap value t. Okay? If t is basically a distance to go along the circle, and that t value that we're going along the circle is going to end up at a specific point, x comma y, and that point is going to be on the circle. So it fulfills x squared plus y squared equals 1. Okay. That t value is also going to correspond with a central angle theta, and that t value is going to have a central angle in radians that is also equal to that distance. Okay? So if you go 7 on the unit circle, okay, that means you've gone 7 radians, and so you've gone all the way around and then some. Okay? From that now, we can define some parts of that circle. There are 6 trigonometric functions that you need to know about. The first one is cosine. Okay? Cosine has an abbreviation of COS. And the cosine of any point on the circle is, anybody remember? Oh, that's tangent, and that's SOHCAHTOA. This is different than SOHCAHTOA. It's what, Lily? It is x. It is the x part of the point that you stop at on the unit circle. Okay? Now, you'll hear us say a lot that everything needs a co. Okay? So again, we would like you to flippity-flop those two. Okay? You can cross out the co on the secant part on the first line, and then write co in front of the secant on the second line if you want. But everything only gets one co. So since we already have cosine, that means that secant then is paired with that. The abbreviation for secant is SEC, and it is 1 over x. Secant is 1 over the cosine. It's the reciprocal of cosine.
What is that up there?
The definition of secant. More important.
Yes, it is.
More important than this.
Very important.
Okay. Next one is sine, and I don't want you to refer to it as sin. Sine is y. So if we're on the unit circle, the sine of any angle or any rep value is the y part of the point that is corresponding to it. Cosecant, or CSC of t, then is going to be 1 over y. Cosecant is 1 over the sine. Tangent is next. I don't want you to refer to it as tan. Okay. It is pronounced tangent. Okay. Tangent of t here then would be y over x. We go back to what Nolan said before, opposite over adjacent. The opposite side on the first quadrant triangle is the y part. The adjacent is the x part. So it's y over x. Its reciprocal is cotangent. And it would be x over y. The abbreviation for cotangent is COT. What do you mean? Reciprocals?
Yeah.
Reciprocals, not opposites. Opposites are positive and negatives.
The reciprocal?
Yes,
Why?
because that's how they're defined.
Is that just what this is?
You don't get a say in that. I don't even get a say in
I
that.
know.
So they're just reciprocals.
Oh, I was gonna say.
Okay?
Oh, are the x and y as in like a axis? So like y, x,
Yeah. Like of the point that they're on.
What do you mean?
So for instance, the first question that I'm asking is this point on the unit circle? How do we know if a point is on the unit circle? No, every point is not on the unit circle.
360 degrees.
How do we know if this point is on the unit circle? I've actually said it already today.
Oh, well.
Only if it's on the unit circle. If it's not on the unit circle, I don't have to find the 6 trig values because 6 trig values don't exist.
If it's an angle.
What's the example of a point that wouldn't be on the unit circle?
1/2 comma 1/2.
How would that happen? But that's between. Okay. Would negative 1/2 comma 1/2 be on the unit circle?
Nope. It's not on the unit circle. There's lots of points that are on the unit circle.
It's gotta have an angle, like a certain angle.
Nope.
30, 60, 18.5.
How do I know if a point is on the unit circle?
Their squared values, x squared and y squared equals 1.
If x squared plus y squared equals 1? Yeah, 'cause it's got to fit the equation of the unit circle. Okay? Remember back over here when I said that the equation of the unit circle was this, and all points have to fit that equation? What I meant by that was, this is the equation of the unit circle, and every point that's on the unit circle has to make that equation be true. Okay? So, how do I know if this point is on the unit circle or not? Plug them in. Okay?
I didn't choose square root of this one.
Yes or no? Yeah, it's on the unit circle. Okay? So now that it's on the unit circle, now all of these relationships that we just found, all of those work. Okay? So, what is the cosine of this angle? -5/13. What is the secant of this angle? -13/5. What is the sine of this angle? -12/13. What is the cosecant of this angle? -13/12. This one might require a little bit of extra math going on in here. What is the tangent of this angle? So it'd be -12/13 divided by -5/13, right? Miss Bushman, what were your 3 words that you just said? Keep, change, flip. Says -12/13 is my keep. I change to multiplication. -13/5 is my flip. So that gives me positive 12 over 5. Which makes my cotangent be 5 over 12. Okay? Let's start building the unit circle once again. Okay? Just a reminder that the unit circle starts out on the right side over there. What are the coordinates of that point? What do you got? 1, 0. 1, 0 are the coordinates of this point. Which would make this be 0 degrees, since that's where we're starting, which would also make this be 0 radians, because that's where we're starting. All the way around the unit circle is how many degrees? 360. So that would make this point also 360 degrees.